What is up, car and tech fans, and welcome back to another garage tinkering video. Last year we made a video where we compared 5 different web-based AI chat applications to see how they differed when it came to writing Arduino code to see which one was the best. And unless you've been living under a bit of a rock this week, you'll know that a massive new player has been disrupting basically the entire AI landscape this week with DeepSeek. So I thought it'd be worthwhile asking the question, is DeepSeek any good at writing Arduino code? So today we're going to test it. In the previous video, which you can check out on the link up here, we looked at ChatGPT, Find, Pi, Perplexity, and Claude came out on top in our comparison, but none of them got the solution that we were looking for exactly right. So we're going to repeat the exact conditions that we used in our previous test just for fairness and see how DeepSeek gets on. And those conditions are that we have a prompt for an application that we want to build. It's pretty simple. We'll look at that in a second. We give the AI an opportunity to produce the code. We test the code, and then whatever errors come up, we tell it back to DeepSeek, let it try and fix any problems, and then re-upload that. So it gets one opportunity to fix its mistakes. It's the exact same conditions we did with the other 5, so I think it really creates a nice level playing field. The Arduino setup that we're using looks like this. It is very simple. We're using a bog standard basic Arduino Nano. There are 2 buttons connected to it, one to pin 6 and the other one to pin 10, and a small NeoPixel strip that is connected into pin 2. It all works. I've tested it this morning. The lights all come on. Everything's groovy. So what is the prompt that we're going to use? And I've copied it from when I did it before. And this is what we're looking at. I need help making an Arduino application that does the following things. We have an Arduino Nano, and connected to pin 2 is a string of 186 NeoPixel lights. I don't actually have that really long string of lights anymore, so we'll just reduce it to 12, because that will mean we can see if the entire strip lights up or just 12 light up, which is a kind of an additional test. There's a button connected to pin 6. When it's pressed, it should toggle whether or not the lights are on. There is another button connected to pin 10. When this is pressed, the colors should cycle through the colors of the rainbow, moving to the next color each time it is pressed. When it reaches violet at the end of the cycle, it should return to red. This is the only bit that I expect a little bit of like flair from the AI, because it has to interpret what the colors of the rainbow are. So it needs to obviously have that knowledge, and it needs to know that it's a looping cycle. So none of the ones previously managed to get that completely right. So it'd be interesting to see what happens. The state, which is a keyword for it, of whether the lights are on and off, and the color that they are currently set to should be stored in non-volatile memory. And when the application turns off and on, the previous state should be reloaded. Now I've helped it along a little bit there by telling it non-volatile memory. So there's certain things that we're looking for, certain ways that Arduinos store stuff in their internal memory. So it's called non-volatile memory. So that's just a little way of helping it along into the right area. Use serial print lines to print on and off when the lights are turned on and off, and print the name and the value of the color when it changes. So this is our setup code. We've got 2 buttons. One turns it on and off. One cycles the colors. It's pretty simple, but again, none of them got it quite right last time. So do we want to use DeepThink to solve reasoning problems? It's not. Is it a reasoning problem? Yeah, let's keep that turned on, because it is really kind of a reasoning problem. And we'll see what it does. I have genuinely not run this before, don't know what it's going to do. We'll see. And really, I only created an account on DeepSeek yesterday, so I've not really had a chance to play with it at all. But I have seen that it does this thing where it thinks first through all the steps and like the rationale behind what it's trying to tell you. And then once it's done all this, it tells you the response at the end. And I like that. I like the fact it's taking the time to go, okay, well, what should my response be? What things do I need to think about before I say the answer? I think more humans could do with adopting that skill. And it is really thinking about this one. So let's see what it's saying before we see the response. So let's tackle this Arduino project. It wants an application for a nano that controls NeoPixels with 2 buttons and saves a state. Let's break down each requirement step by step. Good. First, the hardware. NeoPixel strip is connected to pin 2, buttons on 6 and 10. Need to make sure the buttons are configured with pull-up resistors, either internally or externally. Since the nano has internal pull-ups, I'll enable those to avoid floating pins. It's what we want to see. Next, the first button 6 toggles the lights on and off, so I track the current on-off state and toggle it when the button is pressed. Debouncing is important to prevent multiple triggers from a single press. Maybe use a simple debounce by checking the time since the last press. Again, that's good. That's what we would want to see. The second button, pin 10, cycles through the rainbow colors. Each should advance to the next color. The colors are red, green, orange, green, blue, indigo, violet. Correct. And then back to red. You need to define to colors, perhaps using HSV or RGB conversion for smoother transitions, but maybe start with predefined RGB values for simplicity. Yep, that's exactly how I would go about it. Store the current color index and increment on each press, wrapping around after violet. Again, that is how I would do it, moving through an index of an array. Non-volatile memory storage. The Nano has EEPROM. EEPROM is exactly what I was hoping to see. It's its internal non-volatile memory storage. I did kind of handhold it that though. So I'll use the EEPROM library to save the state on-off and the current color index. When the device starts up, read the values from EEPROM and restore the nanopixels accordingly. However, EEPROM has limited write cycles, so it should only write when the state changes, not every time a button is pressed. So track if the state or color has changed and only save then. Well, every button press forces a state change, so it will do everything every time a button is pressed. So that's just like first misthink, but it'll still work by the looks of things. Serial communication, print on or off when the state toggles, and the color name and value when it changes. Need to map each color index to its name and RGB value. So yeah, we're hoping to see, some kind of mapping between names and colors. So putting all that together, include the libraries, NeoPixel for the LEDs, EEPROM for storage, the constants, pin for NeoPixels, buttons, number of LEDs, EEPROM address for state and color index. Declare the variables, current state on off, current color index, last button state for debouncing, and the last debounce time. That all seems very reasonable. Initialize the NeoPixels, set the buttons to have an internal pull-up, set up the serial communication, read the last state and color from EEPROM, apply them on startup. Then in our loop, check button 6 for presses. When pressed, toggle the state, update the LEDs to save the EEPROM and write to serial. Check 10 for presses. When pressed, increment color index, wrap around after 6, ? Update color, save to EEPROM, print color value. Handle the debounce by checking if enough time is pressed. Wait, the rainbow colors are 7 colors. Red, orange, yellow, green, blue, indigo, violet. So the indices would be 0 to 6. When pressing, increment indexed. If it's 7, reset to 0, or maybe 0 to 6 to go back to 0. So modulo 7. I like the way it's like internally debating with itself. What it's trying to understand here is the difference between an indexed value and a count. So the indexes of an array go from 0 to X. So the very first value is 0. Whereas if you were just counting how many colors are in the rainbow, you'd go red, orange, yellow, green, blue, indigo, violet is 7, because the first one you count as 1. You don't count it as 0. So it's trying to just differentiate the difference there between the number of colors and the index number of colors. But the user says when it reaches violet, next press turns to red. So index 6 is violet, next press goes to set. So it's used my correct grammar to its advantage, and because I will use the word next press returns to red. If I said when it gets to violet it goes to red, maybe it would have looped it in that same press. I don't know. For the colors, predefined array of structs with names and RGB values. For example, struct color has a name and an RGB value. Then it sets up the ones with the different RGBs. So red is red, green, blue. Yeah, orange is this mix. Yellow is full. Yeah, these all seem right. That's green. That's blue. Indigo and violet seem, yeah, about right. NeoPixel color uses color RGB, so maybe use that. I like the way it's going through this. The NeoPixels library set pixel color function can take separate RGB values or a 32-bit color. So for the color of the definitions, maybe create an array of 32-bit colors using the Adafruit NeoPixel color function to generate them. Oh, heck. When the color index changes, set all pixels to that color if the lights are on. If the lights are on, nice catch. So that's a catch that if you're pressing the toggle color button but the lights aren't on, you shouldn't be showing the changed toggle color. For EEPROM storage, save the on-off as a byte, 0 or 1. Good. Yeah, you could do byte or you could do a bool. Oh, can you do a bool with EEPROM? It's been a while since I've used EEPROM because I use ESP32s pretty much exclusively and they don't use EEPROM. But yeah, anyway. And the color index is a byte, 0 to 6. On startup, read these values. If the values are invalid, set defaults. It might set these as a single pair of bytes, which is why it is using bytes. For debouncing the buttons, you use a simple approach where we check the button state has been stable for a certain amount of time, e.g. 50 milliseconds. So when a button is pressed, wait for the debounce delay before registering again. Good. Implement edge detection. Track the previous state of each button, and when the current reading is different and stable, trigger the action. Good. Code structure. This is very in-depth. In loop, read the current button states. For each button, check if the low is compared to the last state. If the state has changed, note the time. If the state has been stable for longer than the bounce delay, then trigger the action. So this is just saying to put in a very simple state manager. So rather than just doing everything on the depress, it's creating a state manager to say what is the current state of the button, and then as the loop happens, has that state changed? So is the button down, up? It's a good way of just forcing this debounce that he's talking about. Wait, the standard debounce approach is to check if the button state has been the same for the bounce delay. So for each button, the state is the read of the button. If the state is not equal to the previous state, then the debounce has happened previously, and then, yeah, so some more state management stuff here. But since our two buttons need to handle each separately, maybe create a helper function to handle the bouncing for each button. Alternatively, track each button, the last state, bounce time, etc. Jesus Christ. Oh my God, there's so much. Okay, we're gonna have to speed up here because it's thought so much about each one of these steps. So we've got a debounce in here. So handle each one separately. Track each button for the last state, debounce. Keep it simple. A simple approach where we check if the button's pressed. Only trigger once per press. Ignoring repeats for a certain time. That's a good idea. Obviously, you could use the Bounce2 library. Bounce2 library is a really good way of doing it, and it is a good debouncing library. A lot of packages that we've looked at on this channel have used that library. But they didn't mention using external libraries beyond NeoPixel and EEPROM. Since the code should be self-contained, perhaps avoid using Bounce2 and handle the bouncing manually. So it's trying not to use libraries. I think if you can avoid using libraries a lot of the time, it's worth it. But there's a difference we've got to look at here between, readability and, maintainability. But to keep the code manageable, it implements a basic debounce with a cooldown, 200 milliseconds since the last press. Alternatively, use edge detection, trigger on the falling edge after debouncing. Yeah, it's really thinking through this. So this is a bunch more stuff. Wait, perhaps this is getting too complicated. Let me outline the steps for each button. For toggle 6, when the button is pressed, toggle the lights on off. Similarly, when it's pressed, do the index. So in the code, each loop iterator, check the state with the bouncing. Read the state, compare to previous state. If it's changed, reset the debounce timer. If the state has been stable for the bounce delay, then check its falling edge to pressed. Okay. I don't think I would think through it in this many steps. I'm a human with a PhD in doing this. But given time constraints, perhaps use a simple approach with a cooldown period for each button press. Yeah, okay, so this is doing lots and lots of thinking through the different ways of approaching this state management on button pressing. So let's move past this because we could be here forever. Okay, so there's still thinking about the different ways of doing it. Wait! I like the way it keeps going, wait! So when the lights are toggled on, set all pixels to the current color and show. When off, clear them. For the color, increment the color index mod 7. So mod 7, which is the thing that just loops it back to the start of the index. Then set all colors to that button. Do the serial prints. Read and write the values. So for each color in the array, have the same name and hex value. Then when the color changes, write them out. So it's just talking about creating a standardized format. Then it's talking about the NeoPixel is a 32-bit. The first byte is ignored. So it's going to try and do it like this, is it? It's going to do byte stepping. So that's what this is shifting the bytes. Not sure I would do it this way, but I'm going to give it the benefit of the doubt. I think what it's going to try and do is do it as a hex value like this. So it's going to store it as a hex value, and then it's going to use this NDN stuff in order to shift the bytes in order to create the values. Anyway, we'll give it the benefit of the doubt again. So again, it's still talking about different ways of creating a color. It's debating the different ways of doing it. That's how I would do it. Yeah, just use straight RGB values as opposed to doing hex number calculations. It's just not worth the overhead. So again, still talking about different ways of handling and doing the colors. It's a bit tedious but manageable. Just okay, so setting defaults from EEPROM, checking whether or not the values coming from the memory are valid. That's good. You need to handle this during setup, so do all this in the setup. I feel like we're getting somewhere now. Then defining different functions to do different things. This is a rehash of what we've basically talked about. I think it's just writing out the code and then confirming it. Seems to have confirmed it, but there's an issue. For the handle, current toggle state is red. If you change to the last, the bounce timer. So it's still debating with itself about this bounce timer issue. I mean, it's thorough. It's definitely thorough. So we can see it's really debating with itself. And it thinks that this is the code. So let's just copy it rather than reading it in here. So this is what it says it's done. So toggle the lights with button on pin 6, cycle through the rainbow colors, state persistence using EEPROM, serial outputs for status changes, and the bounced button inputs. This is basically everything we want. Connect up the hardware. We've already done that. Sequences red, orange, yellow, green, blue, indigo, violet. Repeats, correct. On or off when toggle lights, color name and hex value when changing colors. It's gone for hex, has it? And then EEPROM, so two memory addresses, one for the state and the other one for the color. If I just minimize that and bring in a brand spanking new one of these and paste the code in, let's just take a quick look at it. So we've got the NeoPixel library included, the EEPROM library included. We've got definitions for the pins, the constant of the number of pixels in the strip, what the bounce delay is. We've got the initialization of the strip, defined structure, which is saying what is the name of the color, then it's storing it in its RGB, which is good. That's how I would do it. And then it's defined all those colors as an array object, so it can then like just move through these one at a time and pull out the various values. These are the addresses of the two EEPROM values. So, you know, EEPROM address 0 is going to hold the state, whereas address 1 is going to hold the color. Some global variables to handle, you know, flags. So whether or not the lights are on, what the current color index is. So this is basically defining defaults as well as, you know, doing loading state stuff. When we start up, we set the pin modes to the two buttons. It hasn't set the pin mode of the output one, but shouldn't necessarily be a problem. Begin the NeoPixel strip and then show the NeoPixel strip, which is something you have to do to initialize it. Read whether or not the lights are on and from the state, and whether or not what the current color index is. Read that from the state. If the lights on is greater than 1, lights on is false. Okay, so that's just an error checking. So it's just trying to say is the light on value 0 or 1, which is the only supposedly valid inputs. And same if the index is greater than or equal to 7, it does a reset. So that's good. Update the LEDs and then print the state. So that update LEDs function, if the lights are on, then we set a new instance of the object using that colors array that we've created at the top, and we fill based on the red, green, and blue that we've pulled out of that one based on the index. So the current one, that's good. If the lights are off, then send strip clear and then strip show. So that feels correct. And what was the other function in the top there? Print state. So it's got a separate print. Yeah. So it print whether the lights are on and off. Nice and simple. In our loop, we've got the handle the toggle button and handle the color button. So the toggle button, the on-off button, is just a digital read. If the reading is not equal to the last toggle state, then last to bounce time is milliseconds. So this is just that bounce handling, which is what all this is. If reading is low, then it inverts the flag, and then it updates LEDs, saves the states, and then prints the state. Good. And I presume save state is just EEPROM updates. Yeah. So it saves the state of both of them. That's interesting. That's the first time I've seen something that I wouldn't have done it like that. Because every time you press either button, it sets the state of both the color and the on-off. I would have handled them separately, because at the moment, if I spam on and off, I'm writing to address one with the color change in it, which doesn't need to happen. It'll work, I think, but it's just not quite how I would have done it. And then print state, which we've seen. And then the color button, again, it reads whether or not it's been pressed. It does the bouncing. So if the button's been pressed, then the index increments by 1, but it uses modulus down to 7. So if the number gets to 7, it loops back down. If the lights are on, then update the LEDs. So it's not going to update the LEDs if lights on is equal to false. That's it. Anyway, let's upload the code and see what it does. So right now it's showing nothing, which is what we would expect because the defaults are off and no color. So first button should turn it on and off. We're getting nothing. No serial prints. Nothing happening. What has gone wrong? So something is wrong. Basically, it's printed off, which is what you would expect. The print state runs at the end of setup. So I would expect it to print the current state. But the buttons aren't working. Like I said at the start of this video, I'm going to give this exactly the same test parameters that I gave the other 5 AIs when we tested them, and basically tell it what's not working and see if it can fix it itself. But we need to tell it what is not working, and it's best when using AI platforms for this to try and be as precise and succinct as possible about what the problem is. So the problem is when the application starts up for the first time, the serial prints off in order to show the current state. But when I press either button, nothing happens. And that's about it. That's all I can tell it, really. It would be interesting to see what it thinks the problem is, and how it verifies what the problem is. Does it go through a similar process that, like, a developer of 20 odd years, would go through in order to figure out what was going on? Like, the first thing I would do was remove all of the debounce checking. And just, even though it will probably create errors and make the debounce go too crazy, I would start by removing them and just making sure that we're verifying that we're getting the button input. Use that to verify the EEPROM read write and the actual setting of the lights. But my suspicion, if there's anything wrong with this, is going to be something to do with the way it's done the debouncing. That would be where my gut feels. It's debating with itself a lot here. So it's stepping through the code, which is... Wait, let me check again. It is really having a big think about what it wants to commit to. This is the least committal AI I've ever seen. It doesn't just spit out the answer. It goes, oh, it could be this. Oh, but wait. Oh, no, it's this. Oh, but wait, it's this. But, oh, but wait, it's this. It kind of, it overthinks the problem. And I've noticed that is a habit of all of these kind of chat AIs, is they have a habit of sometimes really overthinking. And I noticed it in particular, while I'll talk to you about it while I wait for this thing to decide what it wants to do. They had a habit of, instead of going back and fixing the root of a problem, they would try and stack more and more solutions on top. So you can sometimes end up with this massively overcomplicated solution, whereas really the answer is just step it back and, go take stuff away to find the solution rather than adding stuff on. It's been a good few minutes and it's still thinking. I'm not sure how long this is going to take. This is potentially, oh, here we go. We've got a solution. The likely issue comes from two factors: shared debounce timing between two buttons and EE prom initialization handling. Here's the corrected code with a separate debounce and improved handling. So I'm guessing in these setup values, yeah, we've got two debounce states now to handle that separately. Okay, rest of the code remains the same. Okay, so I just need to take this bit here and insert it up until the handle color button. Right, upload. We'll come back and look at what it's actually written in a minute. Right now, I just want to see if it works. Right, try again. And nothing still. I'm genuinely surprised we have nothing at this point. Like, what is wrong? So it has not worked at all, which is a shame because I think it's really close. But let's do how I would do this and remove all of this. This is how I would go about solving this. So simplify it. So read it. If the reading is low, then do the thing. It might spam things a little bit, but at least we'll know and verify whether or not there's a problem somewhere else. So that's just on the toggle button. So, right, what does it do now? Right, so it works now, but I can see it's not reliable because it's handling trigger states as various things happen with this button, which is exactly why you need a debounce. But we can now see that that's what the problem is that debounce state. So what actually is the problem? And it's something in this code. So let's see what it's actually doing, where it's gone wrong. If reading, so the value coming in from the button, is not equal to the last toggle state, so it's managing the state of whether or not the button is in or out. If it's not equal, so if it has changed, then the toggle debounce is equal to millis, which is a timestamp of right now. And then it moves on if millis, again, minus last toggle debounce, but it's just set last toggle debounce, is greater than the bounce delay. So this is the problem here. What it's doing is setting this debounce here to a time now, then it's doing another thing immediately. So this thing hasn't had millis here to millis here, and this last bounce delay, it hasn't had a chance to be greater than that the bounce delay. So that's where it's making a mistake. I bet, and it is really not the right way of doing handling of debounces or anything, but I reckon if we got rid of that, and we got rid of that, so just have, if reading is not equal to the last state, then the last toggle state is equal to reading. So it's flipping the state and then saying if the reading is low, so it only then does it on the down. I reckon if we did that on both of these, that one, and then just put, again, not the way I would ever do this in an application, but if we just put a delay in here, and we did that as the code, I've got a feeling that's going to fix it all. Let's take a look. So, left button. Yeah, is now working as you would expect. Off, on, off, on. And the second button, red, orange, yellow, green, blue, indigo, violet. Obviously, there's very little difference between those, but these are RGB strips, so it's going to be limited. And then back round to the start, and they all do that, fine. What about the state management? So yellow and on, turn that off. Turn it on again, it's still yellow and on. And we move to green and off. Remove it, put it back in, still off, but it is still green. Yep, that has fixed it. So it clearly did a lot of it. Great. Once we fixed that small debounce issue, the toggle button on off did exactly what it expected to. The color cycle worked fine. And when we look at the code here, you can see it was doing what we wanted by printing out the color and the hex value for that color, which is what we requested of it. It stored everything into the EEPROM correctly and reset those things when the power was turned on and off to the device. The only thing that it messed up was handling that debounce properly. And it seemed to overcomplicate things, and it was trying to do management of the state and the timing debounce, and it hadn't seemed to realize it was setting a value, then comparing that same value immediately, and hadn't realized that thing hadn't had time to change. I expect that with one more request to it, we could get it to fix everything. And I'm just going to try it for curiosity. Use the bounce2 library to handle the debounce instead. I think if I give it the opportunity to use this external library, then it's going to stop overthinking things. It will rip out everything that's done already and use it as per the way the library works. And that should make things a lot easier. So let's see what it does. I've got a feeling as well that if you turned off this DeepThink, you wouldn't get 10 minutes of it thinking through everything. But, you know, here's the revised code. Right. Dun, dun, dun. So we've got the new bounce2 library in here. We have to initialize it, which we've done. All of this setup of the code stuff here is still the same. Attaching the debouncers to those buttons with a small interval. I would have set this interval here as a global constant, but what are you going to do? Everything else looks pretty much the same until here. So toggle the bouncer just makes life a little bit easier there. So let's just copy that, put it back into here, and give it like one final chance to get everything working. Let's see what it does. So let's have a go. Yeah, there we go. It has fixed it. If I do a few steps, yeah, it's fixed it just by telling it to remove the erroneous bits of code. That is now exactly what we would expect it to run like. So by telling it, basically, this is the actual issue, stop overcomplicating it, remove everything that you've done and use a simple library in order to handle the thing that you are seemingly having problems with. Everything is running exactly as I would have expected to. And I've got a feeling that if it had decided to use the debounce2 library from the offset, which we saw it debate using, it would have probably got this entire thing right first time. When I compare it to the 5 AIs that we looked at previously, which, if we remind ourselves, was ChatGPT, albeit an old version now, Claude, again, an old version now, Find, Perplexity, and Pi, the latter of the 3 I've not touched again since, it has actually got a lot closer to the full solution working directly out of the box than any of those other ones did. And it required very little hand-holding to end up with what is actually a decent, robust, generally well thought through solution. There was one thing that I would change in this final bit of code, and it's the set state. And where they've set the state for both the lights and the color, no matter which button is pressed, I would separate those out and handle those separately. Because you're doing memory writes to each address for each button press, when you don't need to do that, just handle them separately. Each button relates to each individual memory slot. But other than that, I'm actually decently impressed with this. It's, it got very close to being a really good solution in very, very little work. Now, is it perfect? No. And none of these AIs are perfect. They all require a bit of hand-holding to get them to where they need to be. But, 2 years ago, we didn't have this technology full stop. And now within half an hour, if I came into this problem with zero coding knowledge, I could probably get this entire thing up and going. So for entry-level developers who are trying to just, blag their way through this solution finding, it's pretty good. How would I rate it compared to the other 5 that we looked at? Yeah, this is the best one. Well done. Well done, China. You have kicked it out of the park with this. Now, is it 50 times better that I'm hearing people say that this AI is 50 times better. For this, no. 50 times better would have got it right first time. But it's definitely a marked improvement, and everything that it's doing is correct. And I like the way it's stepping through the process, and you can see it debating with itself about the right way to solutionize problems. It's exactly how I work as a developer, but it's still falling into that trap of when something goes wrong, it's trying to move forwards and, tag more stuff on in order to fix it, rather than stepping backwards, which is often what you need to do when you're problem solving as a developer. You need to remove things and go, okay, well, what happens when I remove all this stuff to its simplest form, and then move forwards again from there? Is it going to replace all developers immediately? No, not immediately anyway. But the next few years are going to be both interesting and scary if you're in that space still. So there we go. A look at DeepSeek, or I guess DeepThink, as an option for coding Arduinos. It is very good, and I'm sure I'm going to be utilizing it a lot going forwards for little bits of problem solving. Even me, as a 20-odd year developer, I still utilize software like this to help me identify things that I've overlooked, because we're all human and we all make mistakes, but so do AIs. The only difference is we don't come with a disclaimer that says that. I hope you found this one interesting. Later on this year, we are going to set a new problem and test it across a range of AIs again, because a lot of them have updated in the last 6-8 months since I last did this problem, and I want to give their newest states and their newest versions an opportunity to, compete on a level playing field. So we'll come up with a new problem for them, and we'll test that later in the year. So if you want to see that, make sure you hit subscribe. Otherwise, we've got lots and lots of cool ongoing projects that utilize AI as well as my big old brain. If you want to chat about this stuff, feel free to stick any of your feelings in the comments, and I'm sure there'll be some back and forth about this. Otherwise, you can hop over to my Discord. We're going to create a channel on there just for talking about AI, because I think it's going to be a hot topic going forwards. Link for that is in the description if you wanted to join. That's it for this one, though. Whatever you do with the rest of your day, folks, have a wicked one, and I'll see you in the next video. Take it easy, peeps. Bye-bye.